Hello. Now we are going to look at prisms. And a prism is a type of shape that has a same cross section all the way through its length. So what does cross section mean? Well, let's take this block here as an example. So this is a rectangular prism because if we look at the end of this block, it's a rectangle. So this shape here on the end that forms the end of the block is a rectangle. And if we look down along its length, it seems to stay exactly the same shape as it goes down. If we cut through this metal bar or this piece of timber at any point and we looked at this end where we cut it, it would look exactly the same. So its cross section, its section as we cut across it, its shape as we cut across it, is the same all the way along its length. And if that's true, then we have a prism. And a prism has a useful mathematical fact about it when it comes to finding its volume, because the area of the end is the same as the area of all of the cross sections all the way through. So to find the volume of a prism, you find the area of its end and you multiply by how long the prism is. That's one of the things that's useful about them. They have lots of uses in science and in understanding things in geometry, but for our purposes, they are a tool we need to know because they have this special fact about them. If we want to find the volume of any prism, we find the area of the end of the prism and we multiply by the length. So again, our cross section stays the same throughout. And the volume is always going to be, for any prism, the area of the end, capital A for the area of the end, multiplied by the length. And in the case of this rectangular prism, this is effectively just a box, so we know that its volume should end up being length by width by height. So if we work this out, we have the volume should be equal to the area of the end multiplied by the length. Well, the area of the end is the height by the width, because this is just a rectangle. We multiply the lengths together to get at the area of the rectangle, and then we multiply by the length. Well, now we have height by width by length, and just rearranging, we end up with volume of our rectangular prism is length by width by height. So this is our rectangular prism. Another type of prism that we could end up dealing with is a triangular prism. And as one might expect, that just means that the cross section or the shape of the end is a triangle. And it can be any type of triangle. It could be a right angle triangle. It could be a triangle like this, scalene type triangle. So all we need to do is find the area of the end using the fact that at the area of a triangle is half the base by the height, half of a base, one of the sides, by the height, the distance, the perpendicular distance from that base to the far corner, to the far vertex. So from the base vertically upwards, or I should say perpendicularly away from the base up to the far vertex or the far corner, that's the height we're looking for the area of our triangle. And once we have the area of that triangle, we multiply by the length, and that gives us the volume of our prism. And if we wanted to think about the surface area, the total surface area of our triangular prism, well, we could use a net for doing that, or we can again just think of what a surface area is. It's the area of all the surfaces. Well, I can find the area of this triangle, the area of the triangle that's hidden back here, the area of this side, the area of the hidden side here, and the area of the base of the triangle, or the base of the prism underneath. And I just add all those areas up together to get my total surface area. And as a net, if we imagine that this is the base, so this is the base that we can't see, it's underneath here. We start off with that as our side that we draw. We take that as our anchor, and well, we have a surface. We could say this would be the front of our prism as we're looking at it. Or sorry, this would be the side that we can see of our prism. And then we'd have our front and our back, which we know are our triangular parts. And then this would be the hidden side back here. So we take any of the sides as our anchor and we unfold from there, just like we would with doing any net. And it's important again to note that this fact about the volume of prisms is true for all prisms. If we have any kind of strange shape here, so long as it goes consistently back, it just goes back in a straight bar, it goes back in a straight line, and its cross section should be the same throughout, then we can say we just need to know the area of the end and multiply by the length in order to get the volume of the prism. So that is what we have for our general introduction. And again, this is true for any prism. If we had, say, a circle on the end here and we had a length, well, we tend to call that a cylinder, but a cylinder is really just a particular prism that has a circle for its cross section or a circle for its end. But let's put this into practice with what type of shape is this? Well, it looks like a triangular prism. The end looks like a triangle, and we can see that it goes on for 15 meters. So we're asked to draw the net of the shape, and we're asked to find the volume and the surface area. So let's start off with our net. So we'll take this surface here as being our beginning shape. So we're going to draw this in now. I will draw it freehand. We act as neatly as we can and gives ourselves lots of space on either side because we're going to unfold from this side now. So let's put in the numbers so we can keep track of everything we know. So I have my length of 6 here and I have my length of 15. So this is this rectangle here. So that's a rectangle. I know how to deal with the maths of a rectangle when I find the surface area later. Let's go up and find this surface up here. So I don't know this length here, but can the diagram tell me, or can any information I'm given tell me what it would be? Well, I can see this single dash line here and here. That tells me that this length of 10 meters is the same as the length I'm looking for. So we fill in that information on our diagram. Just like we can fill in that length there must be 15 and this length back here must be 6. So we've filled in all the information in our picture now. So now we can say, well, this box that I need to draw up here is going to be a rectangle. So the surface on top that I can't see down here is going to be 10 wide and 15 long. So it's going to be 15 long, it's going to be 10 wide. So I draw that and I make sure that it goes a bit longer, at least than my 6 did, so that I have everything roughly kept correct. And we can be asked to do this very accurate. We can be given squared off paper and told you must draw this using a ruler and using a ruler and keeping everything very straight and neat. But sometimes we will just draw a net so that we have a picture in our minds of what we need for the surface area. And that's primarily the way I'm approaching it here, so that I know roughly what shape I should be dealing with. So now I have this top surface here. I'm going to go back to my original rectangle here, and I'm going to say, well, what's the base of this going to be? What's this bottom of my prism going to be? Well, it's also 10 wide and it's 15 long. So it's actually exactly the same as the one that I just drew up here. So try and draw that in. We might try and do that a little bit neater, because we don't want to confuse ourselves by drawing it very messy. So that's 10, that's also 15. So I now have the base, I have the side I can see, and I have the top side that I can't see. Now let's draw in our triangular pieces. Well, let's just start off from this piece again. We're using it as our anchor, and we're going to go, these are equal lengths of 10 going out. So I'm going to try and draw this as neatly as I can now, going out to about there. And I know they're 10 and they're 10. When I fold this up, this 10 should fold up to this side and this 10 should fold up to this 10 for the sides of my triangle. And I need to do the same thing out this way. And that's 10. And that's 10. And they all have to match up when we fold everything together. So we now have one of the ways that we could draw this net. There's loads of different ways that we could have unfolded this shape, but this is one of the ways that we could unfold this shape into a net. Now let's get the volume and the surface area. So we'll come back to this for doing the surface area. We'll get rid of the volume first. So I see I have a triangular prism, so I can tell myself the story of how to get that volume. I know that it's going to be the area on the end multiplied by the length. Well, the length is just 15. So how am I going to find this area? Well, I know that the area of the end is a triangle, so it's half the base by the height. So I need to find the area of this end here. So that's going to be, which side do I have enough information for? Well, it's going to be the 6 meter side as being the base, because I know this height here is 8 meters. So that means my area is going to be half times 6 for the base times 8. I can't use the 10 because I don't know how far it is away from this base up to that far corner. What's the perpendicular distance up from that base of 10? So I have to use the 6 as the base. And I end up with the area of that being 24. And then to find the volume, it's just going to be the area times the length is going to be 24 times 15 is going to be 360. And this is a volume, so that's meters cubed. I've multiplied 3 lengths together. And now I need to get the surface area. Well, the surface area is just the area of all the surfaces added together. And as it happens, I already found the area of the triangle, the awkward part. So let's add all of them up. So we're going to have the front plus the back plus the side we can see. And then we have the other side that we can't see. So we'll say side 2. And then we have the bottom. And then we know the front and the back are going to be our 24. They're the triangle parts. And the side, the first side we can see, we'll call it side 1, is going to be 6 meters by 15 meters. Plus the top side here we'll call side 2. And the top side we can't see is side 2, and it's a rectangle, and it's going to be 10 by 15. And unfortunately I run out of space. So we just go on to the next line. And the bottom of our triangular prism is going to also be 10 by 15. And it's just a rectangle. So when we work all of them out, we have 24 plus 24 plus 6 by 15 is 90, plus 150 plus 150. We add all of that up, and we get 438, and this is a surface area, so we're dealing with an area, so that's going to be meters squared. Meters. And that is what we need for our prisms. So again, if we can see that we have an area that we're able to find or that we're given, and it goes back with that same shape all the way through its length, that's a prism, and then we're able to say the volume is going to be the area of the end multiplied by the length of the prism. And that is what we need for now.